Question 14 says, which of the following functions has a maximum value that is 30% larger than the maximum value of the function f of x equals negative x squared plus 4x plus 6? So what we see here is they're giving us an equation for a function, all right, negative x squared plus 4x plus 6, and what we're being asked to do is to determine which of these other functions down here, a, b, c, or d, has a maximum that is 30% larger than the maximum of this one that they gave to us. So bigger, 30% bigger than this point, this graph's maximum point. So what I need to do first is figure out, well, what's the maximum? Because they don't tell me that. I need to know what the maximum value will be for this equation. And then if I can figure out the maximum of these, I'll just see which one is 30% larger. And we'll talk about how to do that in a second. So what I want to do is I want to go to my calculator here. And I've already typed the equation in my y equals. I typed in y equals negative x squared plus 4x plus 6. And if I go to graph, it's going to graph that line for me, that curve. So it goes up, turns, and comes back down. It looks like I can see the highest point, but I'm not 100% positive. So what I want to do is I'm going to go to my window, and I'm going to change my y max here. I'm going to make that a little bit bigger, just in case it went a little above 10. And then I'm going to go back to the graph. So here's what we see. Comes up, turns, and comes back down. Alright, so the graph is complete here. So I can see about where I think this is. It looks like it's happening somewhere around 2 on the x-axis, maybe a little more. And it's going up 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe right around 10. So it looks like at about 210, somewhere in there is where it may be crossing. But again, I'm not positive yet. So to figure out and be more exact, I'm going to go to second and trace to find the exact maximum value. I'm going to choose option 4. And whenever we do this maximum, we have to pick a point on the left side of the maximum. So if this is the maximum, anything on this side of the curve will work for our left bound. So that point right there is good. Then we need a point on the right side of the graph. I'm just going to move this over, get it somewhere over here on the right side. That's plenty good. And we'll hit enter. And then it'll ask you, you want it to guess where the maximum is in between those, and we'll say yes. We'll hit enter again, and there it is. It tells us when x is pretty much 2. Excuse me. When x is equal to 1.999. And this is kind of one of the weird things the calculator will do sometimes, is it will do some weird rounding when it doesn't need to. So the maximum, you see something like this where it's a bunch of 9s or a bunch of 0s, round that off because the maximum is actually at x equals 2. And our y value, this is what we're concerned with. The maximum height of the graph will be at 10. Okay? 2 is where it's happening. 10 is the value we're focused on. So the maximum of our original function is 10. So now what I want to do is I want to go back to my main screen and figure out, okay, if the maximum of the function we have is 10, what would it mean to be 30% larger than that? So what I do is I take 10 plus 10 times 30%, which I want to write as a decimal. 30% is equal to 0.30. So I'm taking the original value plus 30% of that value, and I get 13. That means the maximum for the new graph that we're looking for the correct answer would have a maximum of 13. Okay, so let's see what our options are. We've got an equation, another equation, a graph, and a table. Now the graph is already given to us. This should be pretty easy to see the maximum. It's kind of hard to see right here. I would have to zoom in a little bit. Let's see if we can actually zoom in and see this a little more clearly. Yeah, here we go. Alright, if you look, this has a y value of 30. That's way too high. That's actually 3 times as large, right? It's not 30% larger. That's just 3 times as large. So that's not going to work. So now let's look at the table and then we'll check the equations. So if I look in this table, look at the y values. They're listed as h of x. This is just function notation. So if these are the x's, here are your y's. And it looks like we see a pattern. All right. This is the largest value, 13, and that's the value we were looking for. Now, to know for sure that it's the maximum, that means any points that are the same distance away in the x direction, so like if I go up 1 or down 1, I should have the same y value if this is in the middle of the graph. And in fact we do. Here's 12, here's 12. Go another one over, here's 9, here's 9. So if I went up to 8 right over here, what value do you think it would have? Hopefully you said it would have a value of 4. And then if I went up to 9 after that, it would have a value of negative 3. So that means this point is directly in the middle, so that means our correct answer is going to be C. Okay? Oops. Answer choice C has a maximum at 13. I'm not going to waste the time right now, but you can plug this equation as well as this equation into your calculator and look and see which one has a maximum value that crosses there. Now I'm going to go ahead and tell you that D will not work at all because D doesn't even have a maximum value. Look at this first term. If you remember correctly, the very first term tells you whether the graph is opening up or opening down. If it has a maximum, like B right here does, or like the graph we saw on our calculator right here, then we want that graph opening down for it to have a maximum. Graphs that open up, all right, the actual U shape, have a minimum point. And if it is a positive x squared term, it is going to open up. That's a guarantee. All right, this has a positive x squared, it's going to open up, so this won't even have a maximum. It will have a minimum point. All right. Now chances are, and let's just test this out, I have a feeling that if we plug this in, it's going to have a y value of 13, but it's not going to be a maximum. I think it's going to be a minimum. So let's try plugging this in just to check and see. So that equation was 2x squared. Let me delete all this right here. Let's try 2x squared. And then it was minus 8x plus 21. Minus 8x plus 21. And I'm going to hit second graph to go to the table. And what do you know? Look right here. When x is 2, y is 13. There is 13 showing up, but again, the numbers are coming down to 13 and then turning and going up, so that means 13 is the minimum point. Okay, so that is not correct either. So, even though it had the right value, it was not a maximum, it was a minimum value. The only one that goes up and goes back down and stops at 13 is going to be answer choice C. So that's question number 14. Hopefully that makes sense. Go back and just retry the problem or rewind the video a little bit if you need to see any of that again.